Alright, now I'm going to show you how to connect nodes together using the Aux framework. So here we're going to connect this MTLX image node to this MTLX standard surface node into the emission color input. Before we do that, let's go over how to do that using just the Who module. So in this little script, I just have full paths to both of those nodes. Then we just use the setInput method on the MTLX surface node. We give it an index and the node we want to connect from. So here we don't want to put in an actual integer value for the index. That is likely to break with future updates of Houdini. So what I'm doing here is I'm saying get the input labels and then give me the index of emission color. Now to do this, I actually need to know what the input label is. And that is found here. Get the node and then call the input labels method. And I can see here that I have emission color. All right, if we run that, ta-da, it will connect up. All right, now let's look at how to do this with the Aux framework. With this framework, I went ahead and I am getting the nodes dynamically, so I'm not using the full path. It's because it's a lot easier using the framework. So I can get a child by name, I can get a child by node type, and I don't have to write that code over and over again every time I want to do it. It just lives in the common Aux node class. Alright, so I have my nodes just like I have them before, but these ones are wrapped up in Aux nodes provided by the framework. So to connect up, I just get my surface node here, use the connect from method, and for the first positional argument, we need to give it the node that it's connecting from. In this case, the MTLX image Aux node, and that does need to be a wrapped Aux node. So we don't need to put in the input index, we can actually put in an input label. So to do that, we access the same Aux node and type input underscore, and we should see all these auto suggested input labels to choose from. And if we start typing emission, we get emission color right here. So under the hood, this goes and does pretty much the same thing that was being done down here, as it goes and looks up emission color value and gets the input for that. So if I click over to that class, I see that it is equal to emission color. And so that will be passed in to the input labels.index to give us back our correct index value. So let's go ahead and go back to Houdini and run that. And it worked. Now we are going to change a couple of parameters. First, we're going to change a string parameter, just this file name. We'll set a file path in here. Then we're going to look at how to change a menu parameter. We're going to change from color to float. First, I'll show you using the Who module, then I will show using the Aux framework. Okay, just have our node set up here. We had our set input from before. Now to set the file name parameter, we actually need the name of the parameter. File name is the label, so we see the parameter is file. And then we call set on that, and we set it to some value that we want. And that's it, pretty easy. Setting a menu is less straightforward. Some of the menus can be set using an index, but you wouldn't want to do that anyway. So the values you see here are the menu labels, but these are not the menu values to use to set them. So if we go back in here, if we set this as float, it actually wouldn't work. So we need to set it to the menu item. So back over here in Houdini, I have my signature parameter, and I printed out the labels and the menu items. And we can see that float corresponds with the value default. So these are not very intuitive values down here, especially this for default. So the best way to do it would be to get the menu labels, get the index where it's equal to float, and then pass the index into the menu items that are returned so that we can set that correct value in this set method. Now let's go ahead and run that. Notice color and file name here. Run it, and it changed to float and inserted the new value for the file name. Alright, now let's look at the aux node and do the same. Alright, I have my nodes. Okay, so first, let's get the MTLX image aux node, parameter underscore, and then it was file that we needed. Okay, and then we'll set that equal to the same value as below. Okay, that's done. MTLX image aux node Parm signature, and then menu underscore, and we get all the menu options that we want. We wanted menu float, and that's it. That's all that's needed to set the menu. So what this will do is in place, when this member is accessed, it'll actually set the value for this parameter. So if we right click on this, it brings us over to a little signature menu class, and it looks up the value default for us. Some menus won't work by this value. It'll actually need the integer value, and so there's a backup strategy that will run the integer in case the first value didn't work. As you can see, a much preferred way, at least for me, to write this code. And we can also see that we don't need to guess as much for the file name because the parameters autocomplete here. Now I'd like to show you how to access Houdini nodes from the aux framework. So I have a node set up here in the object network context. This is the MTLX matnet node. Now, first of all, this object network can actually be treated as a node in Houdini. So we can wrap it up in our aux node class and access all of the methods from that class. So here I'm getting the MTLX matnet node as a child of the object node. So here I just call get child by node name. I pass in MTLX underscore matnet, and it returns a Houdini node. Now the naming convention for this is anything that is a Houdini node, just use the word node, and anything that is a node class in the framework should be prefixed with aux underscore and then node. So then we just pass in the Houdini node into the matnet class. Then we will be able to access all of the methods of that class. So not only the methods of the aux node class, but of the matnet node class itself. So any parameters and so on. All right, so a shortcut to do this is to just, from the object aux node, just call get child aux node by name, pass in the name, but then we also have to pass in the node class. And since this is such a common access pattern for these methods, there are some shorthand methods available for these. First is the child method. It's the same as this one up here. It actually calls it behind the scenes. And then the equivalent for get child aux node by name is just aux child. Now let's take a look at different ways to get child nodes. We have get child node. We can get it by the exact name, by a partial name, by the type of node it is. We can get all the child nodes. We can get child nodes by partial name, child nodes by regular expression, and child nodes by type. And even though most of these methods aren't too long, either a few lines of code, some of them are a bit longer, because they are accessed so often, it'll save a lot of time and a lot of lines of code in the long run. We can add exception handling for them and also logging, which is really useful when needing to debug our scripts. One more thing to add here is if we do use the aux_child or the getChildAuxNodeByName methods, it won't support the type hinting for the specific node class that we're passing in. Parm, for example, I'm not going to get the parameters for the GeoNode that I have specified here. So one way I can do it is I can add this code as a type hint after the colon, so that's a bit cumbersome, or I can just import the GeoNode up here from aux.nodes.objectNodes and add that in here. So once I do that, I have all the parameters auto-filling as from before. So it might make sense to do this. It might be best just to stick with the way of doing it of getting child or get child node by name, and then explicitly passing in that node to the node class that we want. All right, now let's talk about logging. Now, I'm not going to go over how logging works in Python. You can go look that up online. realpython.com has a great article on logging in Python. So for the framework, we can import setLogLevel method from the aux module and just use that to set an integer value to set the level. And if I control click over to this method, it'll show you the integer values that correspond to their logging levels. All right, I just have a GeoNode here at the object network level, and I'm calling this method load preset. So that'll load a preset for a method. If I don't pass in any value there, it'll just load the name of the node, which is a default that I have found really handy. So if I can control click over to load preset, here we can see we have our aux logger, and we call debug here to print out the script, and we call info here to indicate whether this was successful or not in running the script. Now, the reason we want logging over printing is when Houdini loads, it loads the aux framework or any Python framework. It only loads it once. So if I added a print statement here, it won't run in Houdini until I restart Houdini. That would be a very painful and slow way to debug our code. You'd also have to delete that statement and restart Houdini again to get it to stop printing out those messages. So with logging, we can turn on and off and set which level of information we want to hear from the logger. Okay, so first I call load preset without adjusting the logging level. Then I am setting the level to 20, which is information, just letting us know out in the console that I've set to 20 for this example. We call load preset again, and I'm setting it to debug level and printing out that I did so, loading the preset again, and then setting it back to 30, which is level warning. How it works is when any of these are set, it will log anything at level 20 or above. So if I set it to info, it'll log info, warning, error, and critical. If I set it to debug, it will log debug and above. All right, so let's go ahead and run that and see what happens. Okay, so we know that it ran before I set it to 20, but there was no logging output. Set it to 20, and then it only has an info message for us that the preset wasn't found, doesn't exist. And then once it's set to 10, we see a debug message and gives us the script that's going to run to load the preset. And then we also get the info message because anything at 10 or above, debug is 10, info is 20, will be logged. And you can also set the logging level here in the Python shell. Just import aux.set log level. Leave it blank, it'll set it to debug level 10, or you can set it yourself to whatever level you'd like. So the way this is used in practice is you'll likely have some deeply looping code that will automate a lot of processes. And if you set the level to debug, it'll actually be an overwhelming amount of information. So it's really nice to be able to set it before the methods you're calling that are having a problem, and then set it back afterward to a less verbose logging level. So if you're still using print statements, stop, Now at the script level, so this script is a toolbar script. We don't have to restart Houdini to get it to be recognized. It was recognized immediately with any changes I make. So here at the script level, it is perfectly acceptable to write some print statements to troubleshoot your code, but you don't want to leave the print statements there for your final script. And you'll want to leave it up to anyone using Houdini to set the logging level in here when something needs to be debugged. Now I'm going to show you how to add a parameter to an HTA node. We are going to add a color parameter after the MyButton parameter, similar to this parameter right here. Okay, so first let's go over the way to do it with the Who module. We have our HTA node. Then we create a color Parm template using the float Parm template method. And here I have just the name and label that I specify, and the rest of these values are particularly for creating the color Parm template. Now to get these values, what we can do is open up a Python shell and create a variable for the color parameter. And then I can call p Parm template dot as code. And this will give me the Python code used to create this Parm template. You can see that some of these would have been a little trickier to figure out on our own or searching on the internet. Alright, so back here we have all those same values in here. We need to get our Parm template group. And here, this colon and then the Who module and the Parm template class, this just gives us type hinting for the variable name. So when I type Parm template group and then the dot accessor, I can see all the methods of that module. Okay, so I have my Parm template group. I use insert after. I'm inserting after the MyButton, as I was showing you before. And then we put in the Parm template that we created. Now after that, we actually need to set the Parm template again. So this Parm template is just a copy of the Parm template, and it isn't going to be set in the node until you call the set Parm template group method for the node. All right, let's see if that works. Cool, we have our new color parameter showing up after MyButton. All right, let's go ahead and delete spare parameters. And let's see how to do this with the aux framework. All right, so I just have my boilerplate code up here, and I'm getting that child node. I have my HTA aux node, and here we create the color Parm template. I'm just giving it a name and a label. The rest of these values are held as defaults for this method. So if I control click on this, it brings me over to that method, and we can see that I already have the values set that need to be there. All right, after that, I just call add Parm template, pass in the new color Parm template, insert after parameter, and here I can either put a Houdini parameter object, or I can just use the name, like I am here. And for this particular scenario, we need a return type. The reason for this is when we add a new parameter, we want to make sure it was created. And for most parameters, it's just going to be the name that we pass in. However, for color, it creates 3 new parameters, each with the name my_color_parm and then RG or B. So if we just hover over this, we can see the doc string for this, and near the bottom there we can see the return type, parameter, and options for that. Okay, let's go ahead and run that. And we see that our color parameter has shown up. All right, in this last section, we are going to talk about generating nodes for the Aux framework. So let's say I have this geometry node helix. So type in helix. It's one of the nodes here at the object network level. And while I'm scripting, I go to my nodes, .object nodes, and I don't have anything for helix. So this is one of the nodes that have not been added yet to the Aux framework. So I have my object nodes over here. Okay, so the way to add it in is to select the node. Don't modify the default name at all, and navigate to the Aux admin toolbar and click on Node Class Generator. Alright, so don't mind my output from before. The output here is that it was generating the node class for type geo and the subdirectory of object nodes, and it lets me know that it has written the file into my directory. Now if I go over back to my script, I now have the helix node. Now you'll need to restart Houdini before this will take effect, but you can script until you need to test it out. Alright, the second important thing about generating nodes is, and this is more of an administrative task, when there's a new version of Houdini and updates to nodes, we actually have a way of regenerating all the nodes that are currently in the Aux node framework. So the way to do that is to have an empty project and to go ahead and click regenerate node classes. Gives you a little warning first. Go ahead and press OK. And we can see that all of these nodes have been regenerated from Houdini. So if any of the nodes have been updated with new parameters or new names and new menu items, those will all reflect in the framework. But be mindful that if you add any nodes or if you run the regenerate node classes, you'll need to create a merge request to get it into the framework so that we can merge it into the main GitHub branch.